In this video, I will be discussing the movement of electrons in organic chemistry. And it's so important for us to understand how electron moves because this knowledge will allow us to predict chemical reaction and write in reaction mechanism. So as important as this is, fortunately, it's actually very easy to learn how electrons move because the movement of electron is very logical, systematic, and predictable, and they follow certain set of rules and pattern. And once we have learned this already, we'll be able to apply this knowledge and really succeed in organic chemistry. Before we get started, we need to distinguish there are two major types of electrons movement. And first one is electron moving within molecule. And second, electron moving between molecule. So whether electron moving within molecule or between molecule, they can be different. The movement of electron within a molecule is also known as the resonance structure. And so please remember that in resonance structure, electrons are moving from one atom to another atom without the rearrangement of atom, because no sigma bonds are being broken or forming. And because the arrangement of the atom remain the same, therefore the molecule is still the same molecule, but basically it has a different way of distributing its electron. So let's say here we have an organic molecule right here, and now it have the buildup of electron in this region right here. So this region in red is rich in electron density, and now this region in blue right here is deficient in electron density. So depending on the stability of the electrons in these two regions right here, if this is not stable, a molecule will try to push its electrons or move its electron around to redistribute the electron on all the atom. So that way the molecule can be more stable. So we can see here in this case right here, electron can be moving within the molecule. And that is basically what happened in resonance structure. So as electrons are moving around, now it may be able to distribute electron in another way. And we can see here in this way right here, the buildup of electron are much better compared to this one, because this one right here has a huge region that is very red, and this region right here they are very blue, meaning they're very rich or poor in electrons, versus over here they are more evenly distributed. So here in this case right here, these two structure are then the two resonance structure, and perhaps maybe the one on the more would then be the more stable resonance structure. So again, these two drawing here are showing the same molecule, but they have different way of distributing electrons. So resonance structure is basically a molecule attempts to stabilize its electron, because if it start out with a set of electrons that are not stable, it will find a way to move it around within the molecule. And again, this do not break in any sigma bond. Okay. Now pi bond can be broken in this process right here, but sigma bond are not broken. So that's something that we will discuss later in the next lecture topic. And now, electron moving between molecules. So this is basically what happened in chemical reaction. In chemical reaction, electrons are moving from one molecule to another molecule. And in the process, bonds are being broken and forming. And that basically change the identity of the substance. For an example, let's say here we have these two molecules on the reactant side. And because if based on this electrostatic potential map right here, we can then see that this two molecule right here has a very high buildup of electrons on this region and this region right here. So basically, it makes this not as stable. So when we allow this two molecule right here to react with each other, the electron-rich region from this molecule is basically being donated to this electron-poor region over here, because this region right here is somewhat blue. It's not very well indicated in here, but it's somewhat blue. So basically the electron is moving from this oxygen on this molecule into this hydrogen right here, let it be blue or positive in this molecule. And that then cause bond to break and now allow electron to be redistributed. And on the product side, this is what we see right here. So this is basically electron moving between molecules in the course of a chemical reaction. And now on the product side, the electrons, after the system had rearranged, and now the electron locate on this product molecule right here. So this has better distribution of electron density, in which the electrons are more stable. And this is basically the driving force of this reaction. So please recognize there are two types of electron movement, and they are different between resonance structures within the same molecule and between molecules that is happening in chemical reaction. Now, whether electrons are moving within the molecule or between molecules, the movement of electrons follows certain basic pattern to them. And it's very important that we learn to recognize this basic pattern right here. And once we have learned and recognized and understand this basic pattern right here, we'll be able to put them together and write in reaction mechanism and predicting product of the reaction. And basically the movements of resonance or chemical reaction are then known as mechanism. And to show the movement of electron, we use curved arrow. So here an example of a curved arrow. So this is not a straight arrow, but a curved arrow. And this arrow right here is intended to help us show how electrons move. Now, on one end of this arrow, on this end right here, this is called the tail of the arrow. And then the other part where this arrow is pointing toward, this is called the head of the arrow. So this arrow right here on its tail, it starts from the electron source, because this arrow right here is intended to show the movement of electron. So therefore, we have to start out with the source of electron. And the source of the electron is basically atoms in the molecule. They have negative charge on it, or has lone pair of electron, because this is basically the sources of electron. Electrons are found in lone pair, especially with lone pair on atom with negative charge on them. And the source of electron can also be electron-rich bond, such as double or triple bond, or any region that is rich in electron. As we write and learn how electrons move, we need to start drawing our arrow from those electron-rich region, or the electron source. And now on the head, then this is where the electrons acceptor would be. Wherever they can accept electron, we will pointing the arrow to that particular area. And the electron acceptor are basically atoms that have a positive charge on it, because positive charge attract electron. So therefore, electron will then be moving to things with positive charge on it. Now, partial positive charge can also attract electron as well. And same thing with empty orbital. Atom with empty orbital can accept electron, since the orbital do not already have electron on it, since it is empty. And now there are two types of arrow. A full arrow, which is the arrow that we have seen above. So this is a full arrow. A full arrow shows two electrons are moving. So anytime we have two electrons moving, we'll be using the full arrow. Versus a half arrow. A half arrow is drawn as follows. And this basically means one electron is moving. And a half arrow is basically used in the case of radical reaction, which we'll see later here in this class. Now, each curved arrow has unique meaning to it, because it shows us how the electrons are moving. And therefore, we need to learn the meaning to each of the movement in the arrow. And don't forget to actually correct for formal charges, because as electrons are moving, the formal charge will also be changing as well. So therefore, as we draw our arrow and show an electron moving, we need to keep in mind of the formal charges and how they are changing as well. And below, here are some of the common curved arrow. And throughout this whole class right here, we'll be using this common curve arrow right here. So it's quite important that we understand what is the meaning to each of this arrow. So here is the first types of common curve arrow. Arrow involving the movement of electron from lone pair to an atom. When electron move from a lone pair to another atom, then that basically tells us a bond is forming between those two atoms. So here's an example of it. A lone pair of electrons on one atom is then moving to another atom. So that's what that means, from a lone pair of one atom to another atom. So here in this case right here, what this arrow means is that the atom A is taking its lone pair electrons and then donate this lone pair electron to atom B. And in the course of this, a bond would then be formed between atom A and atom B. And this, if we were to follow this arrow, this would then be the products. And now, the lone pair of electrons that initially belonged to A has now become a part of the bond pair electron that now been shared between the atom A and the atom B. So that would then be the meaning of this arrow. Again, so this involves a lone pair moving to an atom. So the atom A donates its lone pair of electrons to atom B, and the lone pair is now used to form a bond between atom A and atom B. And similarly, we can also have a lone pair from an atom that carry a negative formal charge to an atom B that now carry a positive formal charge. And this is actually even better than what we have seen from above, because now in this second example right here, A is very rich in electron, so it has a lot of electron to move, and now it moves to something that is positive, which can attract electron really well. And if we were to follow this arrow right here, it would now become the following: A and now B. And actually, going back to the previous example, we actually forgot to accommodate for the formal charges. So can you see how would the formal charges be in the first example would be changed? So here in this case, initially A is neutral and B is neutral. If A going to donate its electron to B, A would then become positive, and then B would then become negative. So that's how the formal charge would be changing in the first scenario. And now please be aware of the following. A is now become positive 1 and B is now negative 1. And the reason why that is the case is that as A give an electron to B, it basically donate 1 electron to B. So before, both of these electrons as a lone pair, they both belong to the atom A. But as this electron are now used to form a bond between A and B, technically speaking, in a bond, there's 2 electrons and 1 electron belong to each atom. So basically now, of this pair of electrons here, only 1 belong to A, and now the other one belong to B. So therefore, we can see that A is given 1 electron away, and B is given 1 electron. And because B start out it is neutral, when it gain 1 electron, it now become negative 1. So it's really important that we keep track of these formal charges right here. And now in the second example, in this case right here, A initially it is negative, so rich in electron. When it move its lone pair to a B, it basically will be given 1 electron away. So right now, if A is negative, and when it give 1 electron away, electrons are negative. So when you give something electron away, you will then go down in your negative charge. You will become more positive. So therefore, A would now be going from negative 1 to now neutral. And for B, initially, this is now positive 1. When it gain 1 electron from A, it now become neutral as well. So that is what happening. And now in this last case right here, so electron it moved from A into B, and now A is negative. Now if we have to start from the sources of electron in all this case right here, and the source of electron will then be the lone pair of electron. Okay, so here in this case right here, starting from A, and A rich in electron. So now it's moving to a B. And in this case, a bond will then be formed between A and B. So that's the meaning to this arrow. And now A initially is a negative. When it gives its electron away to B, it now will become neutral. And as for B, initially this is neutral. So when it gains the one electron from A, it now becomes -1. So that's how the formal charges of this would be changed. And now the second common types of error that we can expect to see. So from bond to atom. So electron move from a bond to an atom. And when this happens right here, a bond will be broken. Okay, and please note the following. As bond breaks, the electron that is now part of that bond pair electron will then move toward the atom with a positive charge, or the more electronegative atom. Because whenever a bond breaks up, then the electron will then be attracted to a thing that is positively charged, right? Or the more electronegative atom, because the more electronegative atom would like to have the electron with it, so they love electron more. So in this case right here, let's say here we have atom A and atom B, and now this is the pair of electrons between them, and these are the formal charges of A and B. So in this case right here, if we go into break a bond, so from a bond and here, that's where the electron will be. When we break this now go into A. And the reason why the electron is go into the atom A is because the atom A has the positive formal charge on it. So this basically attracts the electron that is a part of that bond. And in fact, due to the positive charge on A, that would attract this bond electron or bond pair electron here to itself. And that basically breaks the bond between atom A and atom B. And so when we follow this arrow right here, now this will become the following. A would now end up with the lone pair of electron. So the bond pair now become the lone pair on A. And now B will be losing that electron. And in this case right here, initially A is positive. As the electron move to A from a bond pair into a lone pair, technically speaking, A is now gaining one electron. So initially it will positive. When it gains one electron, it now will become neutral. And as for B, so as in this arrow right here, B is losing one electron to A. And initially this is -1. So when something -1 loses an electron, it will then become a neutral. And now there's no lone pair on it. So that would be the meaning to this arrow. And now, in this other example down here, so we have a bond between, let's say here, carbon and a fluorine. And in this case right here, if we were to have a bond breaking, then we can have a bond from this electron from this bond in moving, and it has to move toward the more electronegative atom. And again, let's say this is a carbon and this is the fluorine, or this is the more electronegative atom. So if this bond go into break, it will be going from the bond to the atom, and it has to be to the atom. They now are part of this bond, but no other atom in the molecule. So again, it has to go to this atom right here, that is part of this bond. And when we follow this arrow, this would be then become the following. So the fluorine would end up with a lone pair of electron on it. And initially the carbon, or this atom C over here, this is neutral. So as its electron is moving to F, to this atom F, or the fluorine, then now we can see the carbon will be losing an electron. So therefore it will go from neutral to positive. And as for the fluorine, when it gains an electron, it will go from neutral to now negative. So that's how its formal charge will be. And in this other example over here, if we were to have this scenario, and now a bond breaking, then we can have electron going from bond to atom. So which atom will end up with electron? So here in this case right here, it has to go to the atom A. Now why atom A? And the reason why it goes to atom A, because atom A do not already have electron on it. Here in this case right here, because the atom B is now negative, meaning it's rich in electron. So will something that rich in electron would want electron even more? No, because all atoms want to be as neutral as they can be, so they can be more stable. So here in this case right here, if this bond is going to break, the electron will then move to the atom A. And following this arrow, we will have atom A end up with a lone pair of electrons. So the bond pair between A and B now become a lone pair on the atom A. And as for atom B, it will not have any electron on it. And the charge will become neutral. So again, if something is negative, losing an electron, it will become neutral. As for A initially was neutral. So when it gains an electron, it now will then become negative. So that will be the products following this arrow. And we can also have arrow where electrons move from bond to atom by involving a multiple bond. So in the course of a multiple bond, like such as double or triple bond, there's many pair of electrons in them. So basically, this pi bond, so this you basically make up the pi bond right here. And in fact, it is the pi bonds or the pi electron that have been broken. In the course of a multiple bond, there's one sigma bond and there can be one or more pi bond in them. It is actually the pi bond that being broken because the pi bond are weaker. And now the electron will then go to whichever atom A or atom B, depending on whichever is more electronegative. So let's assume this is the more electronegative atom. So we can basically have a double bond where the pi electron or the pi bond will be broken, and now it goes to the more electronegative atom. Let's assume B is the more electronegative atom in this case. When we follow this arrow right here, this is what we will have. So again, there's two bonds and only one bond is broken, so there's one bond remaining. And in this case, B would also end up with a lone pair of electrons. So this bond pair that make up this pi bond now become a lone pair of electron on this atom B. And as for the formal charges, A, it loses an electron, so it becoming positive. And for B is gaining an electron, so now it becomes negative. And now, the third patterns. From lone pair, electron moving from lone pair to bond. And this is basically what happened in the formation of multiple bond. So only when two atoms are already bonded together. So this is what happened in this case. So we'll only be able to see this whenever we already have two atoms bonded together. And the lone pair from one atom can be used to form a pi bond to the other atom to create a double or the triple bond. So here in this case right here, A and B are already bonded together. And now B in this case right here has a lone pair of electrons on it. So if A is able to accept the electron, B can then donate the electron by taking the lone pair from B and then donate this into this bond. And the meaning of this is that B is now sharing one electron with A, and that forms the bond between A and B. So we will be going from a single bond to now a double bond. And as for the formal charges, if A was positive before, it would now become a neutral, sending gaining an electron. And in this case, B is negative. When it gives the electron away to A, it now becomes neutral as well. So again, this arrow right here means that B is given one electron to A. And it's using that electrons to now form a bond between A and B. And similarly, if we start out with a double bond already, and we have a lone pair of electrons on B, and now A can accept electron because A have a positive formal charge on it, then now the electron can also be donated in, and in this case right here, we'll be producing a triple bond. And as for formal charges, A would now go from a positive to neutral, and B will go from negative to neutral as well. So that another types of common bond pattern that we can expect to see. And now, looking beyond, many of the basic curves that we discussed above will be combined and applied as we write reactions, predict reaction, and write in reaction mechanism. So many of the steps that we have seen already involve this one step, but in reaction mechanism, we combine many of these arrows together to produce one meaningful step. So that's something we can expect to see later when we learn about resonance and reaction mechanism. And additional rules will then be discussed then.